Okay, let's unpack a scenario that I have a feeling is going to hit uncomfortably close to home for a lot of us. It certainly did for me while we were prepping for this.
I have a feeling it will.
Yeah. So picture this. It's 9 p.m. I'm sitting on the couch, and I make a very clear, very clean executive decision.
Okay.
I say to myself, no phone tonight. I am going to read a book. I'm going to, I don't know, stare at the wall, just decompress like a functioning adult. No phone.
Sounds like a solid plan.
Yep.
Very reasonable plan.
It was a great plan for about 4 minutes because 10 minutes later, I kind of regain consciousness and I am deep in a scroll hole on social media. I'm looking at photos of a wedding for people I don't even know. And the scary part is I don't remember picking the phone up. It's like I never made the decision at all.
Right.
So the question we are tackling today is that just weak willpower? Am I just bad at being a person? Or is something else running the show?
It is definitely not just weakness. And honestly, that experience, that phantom scroll, as you call it, that is the perfect starting point for our deep dive today.
Okay.
Because what you're describing isn't a failure of character. It's a conflict between two very distinct modes your brain uses to navigate the world.
2 modes. Okay, so we're talking about the pilot and the autopilot.
Exactly. You have the I choose mode. That's the pilot. It's a slow, deliberate, thoughtful. That's the version of you that decided no phone.
Right, my best self.
And then you have the autopilot mode, which is fast, automatic, and it runs entirely on habit.
And based on the research we looked at, autopilot isn't just a metaphor for, zoning out. It's actually rooted in a very specific, very physical navigation system in the brain.
A biological GPS.
A biological GPS.
That's the twist. We tend to think of navigation as something we do with a map, in a car, or hiking. But the science shows that the brain uses the exact same hardware to navigate your evening choices as it does to navigate a city street.
And the scientists who figured this out actually won a Nobel Prize for it.
They did. For discovering the system that helps your brain answer 2 really basic questions. Where am I, and where do I go next?
Which is just wild to me. A Nobel Prize for the thing that makes me grab my phone when I really don't want to.
In a way, yeah. Because that system handles navigation in physical space,
Right.
but it also handles it in conceptual space.
Yeah.
Like choosing what to do next on a Tuesday night.
So my inability to put the phone down is technically a navigation error.
It's more like a navigation preference.
Yeah.
But before we get into the phone scrolling,
Mm-hmm.
we really need to look at how this system shows up in the physical world.
Right.
Because there's this one specific phenomenon that kept coming up in the sources, and I know you resonated with.
Oh, you mean the kitchen doorway moment?
The kitchen doorway moment, yes.
This is the bane of my existence. I'm in the living room. I realize I'm thirsty. I think, okay, glass of water. I walk to the kitchen. I cross the threshold of the doorway, and poof, it's gone. Blank. I'm just standing there in the kitchen thinking, wait, why am I in here?
It's such a classic human experience,
Mm-hmm.
and usually we just beat ourselves up about it. We think, oh no, my memory's failing, I'm losing it.
I instantly assume it's early onset cognitive decline. Every time.
But it's not actually bad memory. It's what researchers call a context switch, or an event boundary.
An event boundary. Okay.
Think of your brain like a computer browser, or maybe a video game. When you cross a doorway, your brain has to update the whole scene.
Okay.
You've left the living room environment, you've entered the kitchen environment, new light, new objects, new possibilities. It's like hitting refresh or loading a new level in a game.
So my brain's busy rendering the new graphics of the kitchen.
Precisely. And in that split second of processing the new environment, oh, there's the fridge, there's the sink, the original goal, get a glass of water, just gets dumped from the temporary cache.
It loses priority.
It loses all priority while the brain processes the new map. So your brain basically says, new scene, new task list, delete previous temporary files.
Wow. Okay, that makes me feel a little better. But I'm still stuck on this navigation idea. Forgetting why I walked into a room. That still feels more like a glitch than a GPS.
Okay, fair enough. Let's try a different scenario. Think about the supermarket. You're done shopping, you push your cart to the front, and you have to choose a checkout line.
Right. I don't pull out a map for that. I look for the shortest one.
But think about what your brain is actually doing in those, 3 seconds? You're not just looking at length.
No, it's a whole calculation.
Right, you're scanning.
Yeah.
Which cashier is faster? Who has a cart overflowing with 50 items versus someone with just a basket? Is that person pulling out coupons? Is there a kid about to have a meltdown in lane 3?
Oh, absolutely. I am calculating risk, time, and potential annoyance variables instantly.
That rapid calculation, that's a map of options. Navigation isn't just about north, south, east, west. Fundamentally, it's about answering what is my next best move.
Okay, that I can see, but I'm going to play the skeptic here for a second. This all sounds very logical, but it still feels like psychology. Like we're just using maps as a nice way to describe thinking.
Mm-hmm.
You mentioned a Nobel Prize. So where's the hard science? Where's the proof this is happening at the level of brain cells?
I love the skeptic's challenge. And you're right to ask, because Nobel Prizes aren't given for pretty analogies. And this brings us right to the 2014 Nobel Prize in Physiology or Medicine.
Okay.
It went to 3 scientists, John O'Keefe, and then the duo Maybrit and Edward Moser.
Let's break that down, because the reading on this was, it was dense, but fascinating. Let's start with John O'Keefe.
So we have to go way back to 1971. John O'Keefe discovered a specific type of cell in a part of the brain called the hippocampus.
The hippocampus, right? Memory center.
Exactly. So he was monitoring the brains of rats moving around in a box.
Hmm.
And he found that certain cells would light up. They would literally fire an electrical signal only when the rat was in one specific spot in that box.
So if the rat is standing by the food bowl, one cell fires. If it moves to the water bottle, a totally different cell fires.
Exactly that. He called them place cells. You can think of them as little "you are here" markers,
Yeah.
like pins dropping on a digital map.
Okay, so the brain has pins. I am here. But a single pin on a map doesn't tell you how to get anywhere else.
Correct. It just tells you where you are right now.
Mm-hmm.
And that's where the Mosers come in, much later, in 2005.
Okay.
They were looking at a nearby region of the brain, the entorhinal cortex, and they found something that it blew the scientific community's mind. They found grid cells.
Grid cells, right. This was the part where I had to read the paragraph 3 times, because these don't just fire in one spot.
No. These cells fire in a repeating pattern. If you were to map out where a single grid cell fires as an animal moves around, it creates this perfect hexagon, a honeycomb pattern across the entire space.
A hexagon in the brain.
A hexagonal grid that overlays the entire environment. It's essentially a built-in coordinate system. These grid cells are what allow the brain to measure distance and direction.
So O'Keefe gave us the location pins, the "you are here" dots, and the Mosers gave us the longitude and latitude lines that connect them.
That's the perfect way to put it. Together, they form a measurable biological navigation toolkit. And this allows for something called path integration.
Path integration.
So think about this. You wake up in the middle of the night, it is pitch black. You can usually still walk to the bathroom without smashing into the wall.
Right.
You can't see any landmarks. You can't see the pins.
Yeah.
So how do you do it?
I guess I feel my way there. I just kind of know.
That knowing, that feeling
Yeah.
is your grid cells at work. They're calculating your movement. I took 2 steps forward, 1 step to the right, and they're updating your position on your internal map in real time.
Yeah.
It's pure dead reckoning.
That is incredible. So even in total darkness, my brain is drawing a map.
Yes. And before this discovery, navigation just felt like this mysterious sixth sense. We knew we could do it, we just had no idea how. It's like the shift in medicine from saying people get sick from bad air to discovering microbes. Suddenly you can study the mechanism.
Okay, so navigation is real. We have place cells, we have grid cells, we have a GPS coordinate system in our heads. But we started this whole conversation with me doom scrolling on my phone.
Right.
So how do you leap from finding my way to the bathroom in the dark to why I can't stop scrolling?
This is the crucial bridge. The brain is incredibly thrifty. It doesn't like to build new tools if an old one works just fine.
Reduce, reuse, recycle.
Exactly. So the research shows that the same system that helps you follow physical routes also favors familiar routes to save energy. And a route can be physical, like driving, or it can be behavioral.
Okay, give me a concrete example.
Let's use driving first. You're driving home from work. You have a conscious goal. I need to stop at the pharmacy. It's on the way, but you have to turn left at an intersection where you usually just go straight.
I know exactly where this is going. I've lived this exact scenario.
You're driving, you're thinking about dinner, maybe you're listening to this deep dive, and suddenly you're pulling into your own driveway. You're 3 blocks past the turn. You completely blew past the pharmacy.
Yes, and I'm sitting there in the car thinking, how did I end up here? I told myself 5 times to stop. It's scary. It feels like I wasn't even driving.
In a sense, you weren't. Your autopilot was. Your brain had 2 potential routes on its map. Route A, the pharmacy. That's a narrow, overgrown trail. You haven't taken it in weeks. Route B, home. That is a wide, well-lit, 6-lane superhighway. You take it every single day.
So when my conscious mind, the pilot, got distracted, autopilot just grabbed the wheel and took the highway.
It chose the path of least resistance. It
Yeah.
costs way less mental energy. And it's a feature, not a flaw. If you had to consciously navigate every single turn home, you'd be exhausted.
Right.
But it becomes a huge problem when it hijacks a conscious goal.
And this applies to the phone.
Exactly the same principle. With the phone, the route isn't a street. The route is a behavioral loop. It goes. Feeling of boredom, which triggers the action reach for phone, which leads to the destination scroll.
And because I've done that loop thousands of times, it's a superhighway in my brain.
It is. Your brain treats boredom as a location on the map and phone as the quickest, easiest path to relief. Your pilot says, let's read a book. That's the new path. But your autopilot sees that boredom signal and immediately merges onto the phone highway.
So autopilot is both a superpower and a trap.
Perfectly said. It's a superpower because it preserves your energy. But it is a trap when you're trying to change. Autopilot loves the familiar. Familiar apps, familiar snacks, familiar arguments, familiar ways of avoiding hard work.
Wow. So we get not what we planned, but what we practiced. That's actually kind of terrifying.
It can be humbling. But knowing the mechanism is the first step to, hacking it.
So what do we do? If this system is hardwired, this Nobel Prize winning efficiency machine, how do I actually take the wheel? I don't want to turn my life into this constant battle where I have to white knuckle every single decision.
And you shouldn't. You can't fight your own biology, but you can manage it. And based on this research, there are two, let's call them gentle steering wheel techniques that can help you intervene without burning yourself out.
Okay, lay them on me. I need one for the doorway moment and one for the phone moment.
Let's start with the doorway.
Yeah.
Technique number 1 is beacon before you move.
Beaconing, like a lighthouse.
Exactly. Remember the context switch. When you change rooms, the brain wipes the slate. By beaconing, you're placing a high priority tag on that information to keep it safe.
So how do I actually do it?
Before you stand up, before you cross the threshold into the new room, just say your goal out loud, or at least very clearly in your head.
So I just say, I am going to the kitchen to get water.
I am going to the kitchen to get water. It sounds almost too simple.
Yeah, it does. Does that really work?
It does. You're effectively telling your brain, hey, this file is important. Do not delete it during the system update. You're carrying the beacon across the event boundary.
So I'm not relying on a passive memory. I'm actively labeling the mission.
I like that.
Okay, now for the harder one. The phone, the scrolling, the habits.
This brings us to technique number 2, the 2-second question.
The 2-second question.
Okay.
When your hand reaches for the phone, or the sweets, or the remote, just try to pause for exactly 2 seconds.
Just 2 seconds.
Just 2. 1, 2. And in that tiny pause, you ask yourself one question. Is this my plan or my habit?
Is this my plan or my habit?
Okay.
But I have to ask the honest question. What if the answer is, it's my habit, and I still really want to do it?
Yeah.
What if I ask the question, and I still want to watch the cat videos?
That is totally fine.
But really, you're giving me permission to fail.
It's not failure. Because if you ask the question and then you choose to scroll, you have still won something incredibly important.
You've moved from autopilot to awareness. Even if you do the same action, it becomes a conscious choice, not an automatic slide.
I see. So the victory isn't stopping the action. The victory is just waking up.
The pause is touching the steering wheel. That's the whole move. You are verifying that you are the one driving, even if you decide to stay on the same road.
That's a really helpful distinction. It takes the pressure off being perfect and just puts the focus on being present.
Exactly. You can't navigate a map you aren't even looking at.
Okay, I want to circle back to something you mentioned earlier. Why does the doorway steal the goal? The idea of water, but I don't forget how to walk.
Ah, that's a great question. It's about different types of memory. The route, the walking, the motor skills, that's stored deep in the basal ganglia. It's a body habit.
Right.
But the goal, get water, is fragile. It's held in your working memory, which is tied to the specific context you were just in, tied to the couch, the feeling of being thirsty there. When that context vanishes, the link weakens.
So memory isn't just one thing. It's memory in a scene.
Exactly. And your internal map, those place and grid cells, that's the system that organizes all those scenes.
This feels like the right time to pivot to the more serious side of this. We've been talking about phones and water glasses, but the sources all emphasize that this research has huge implications for medicine.
Yes. This is why the Nobel work was so critical. It wasn't just about understanding how rats find cheese. When we look at conditions like Alzheimer's disease, One of the very first symptoms is often disorientation,
Getting lost in familiar places.
getting lost,
Mm.
not knowing which way is home. And we now know that the internal cortex, the exact area where those grid cells live, is one of the very first parts of the brain to degrade in Alzheimer's.
Oh, wow. So the grid, the coordinate system itself starts to break down.
That's the leading hypothesis. The map itself dissolves. The grid cells stop firing correctly, and that internal sense of direction and distance just fails.
That's heartbreaking.
It is. But understanding this machinery, how the math is supposed to work, is what gives researchers hope. It helps them design better tests to catch these changes early.
And it also changes how we treat people, right? It's not just diagnosis.
Absolutely. It helps us design better environments for people with memory loss. And it moves the conversation from why are they acting confused to what is mechanically changing in their navigation system. It's about dignity.
So bringing it all back home, we started with the question, who's driving? Me or my brain?
And the answer, of course, is both. It's a co-pilot situation. Autopilot is there to keep you functioning, to save your energy. But conscious choice, that pilot mode, is what helps you change direction.
And the skill is just knowing which mode is active at any given moment.
Right. And using that tiny pause, that 2-second gap, to switch modes when it really matters.
I love that. It isn't about fighting your brain, it's about collaborating with it.
Exactly.
Well, this has definitely made me rethink my evening routine. I'm going to try the 2-second question tonight. We'll see if I end up reading the book, but at least I'll know I made the choice.
And that's the win.
I have one final question for you listening right now. We talked about the phone, the pharmacy, the kitchen. Here's the challenge. Where did Autopilot drive you today? Was there a moment where you ended up somewhere physically or mentally that you didn't actually intend to go? And where could a simple 2-second pause have changed the entire route? Think about it. Thanks for diving in with us.